let's find the distance between a point and plane. The distance between a plane and a point Q that's not on the plane is the distance equals the magnitude of the projection of n times the vector PQ. Now we're not going to use that one. We're just going to use the vector PQ times the normal vector all over the magnitude of the normal vector. Now P is a point in the plane, n is normal to the plane. To find a point in the plane given by ax plus by plus cz plus d equals 0, and a is not equal to 0, let y equal 0 and z equal 0. Then solve the equation ax plus d equals 0, and then you find that point negative d over a is 0, 0, which lies in the plane. So find the distance. Let's try an example. Find the distance between the point Q and the plane given by 3x minus y plus 2z equals 6. So it says here, we're going to let y equal 0 and z equal 0. So let y equal 0 and then let z equals 0. And so we're going to do that here. We're going to make these 0. So let me write that out. 3x minus 0 plus 2 times 0 equals 6. So that's 0. So we get 3x equals 6, or divided by 3, x equals 2. So this point is going to be 2, 0, 0. So the vector, we're looking at PQ. And so remember, this is P here. Q is up here. So we're going to subtract. We're going to find the component form first. So the terminal minus the initial, so Q minus P. So this is 1 minus 2, and then 5 minus 0, and negative 4 minus 0. So V is going to be negative 1, 5, and negative 4. Now the normal vector, or the normal to the plane, n is normal to the plane, so this is n here, so therefore we just take the coefficients, so therefore n equals 3, negative 1, and 2. And so to find the distance, this is going to be the vector PQ times n over the magnitude of n. Okay, so we found everything we needed here. And so PQ, we know, is this here, and we're going to multiply it to 3, negative 1, and 2. So remember, this is negative 1 times 3 plus 5 times negative 1 plus negative 4 times 2. So let's do that. So this is going to be negative 1 times 3 plus 5 times negative 1 plus negative 4 times 2, and it's absolute value, so it's going to be positive. Distance is positive over the magnitude of n. So that is going to be the square root of 3 squared plus negative 1 squared plus 2 squared. So this will be the absolute value of negative 3 minus 5 minus 8 all over. This is going to be the square root of 9 plus 1 plus 4. So this is the top is going to be 8 plus 8 is 16. So absolute value of negative 16 over the square root of 14. And so the distance is just 16 over square root of 14. Of course, you could rationalize the denominator and reduce as well. Okay, so that is the distance. So try this example here. Find the distance between the point Q, negative 6, 2, and 1, and the plane given by 2x plus 5 minus z equals 3. Now, as a hint, you don't always have to let y equals 0 and z equals 0. It is up to you as to what you want to choose. It's arbitrary, so it just depends on what works best. And so you don't always have to do that, and you'll see that when I work out the example. So try this out. And I'll have the answer for you in a minute. So in this case, I let x equal 0 and y equal 0. And then so when I did that, So I made this equals 0 and this equals 0. So notice all I'm left with is a negative 7 equals 3. And so that's why I chose x and y to be 0. So they're a little bit nicer to work with. So therefore, z is negative 3. So the point on the plane that I'm using is 0, 0, negative 3. Now to find the vector PQ, I did negative 6 minus 0, 2 minus 0, 1 minus a minus 3. So therefore, that is negative 6, 2, and 4. And then I got my normal to the plane, n is 2, 5, and negative 1. And therefore, I found that the distance is 6 over square root of 30. And of course, you can rationalize the denominator. So 6 root 30 over 30, or just square root of 30 over 5. So again, the choice of the point P in example 6 is arbitrary. You can choose a different point in the plane. Number 1, to verify that you find the same distance, or because it is more convenient to pick another number. Now just real quick, because you have to sketch some planes in space in the homework. And so as discussed in section 11.1, when a plane in space intersects one of the coordinate planes, the line of intersection is called the trace of the given plane in the coordinate plane. To sketch a plane in space, it is helpful to find its points of intersection with the coordinate axes and its traces in the coordinate plane. So let's look at this example first. 3x plus 2y plus 4z equals 12. So I find that the quickest way to sketch this plane is to just find your find x, y, and z intercepts. So for example, to find the x-intercept, you're going to make y equals 0 and z equals 0. And so notice if I do that here, those will cancel out. So I'm going to be left with 3x plus 0 equals 12, or x equals 4. So that is going to be the point 4, 0, 0. Then for the y-intercept, I'm going to make x equals 0, z equals 0. So this is going to be 0 plus 2y plus 0 equals 12, or y equals 6. So therefore, this is 0, 6, 0. And then for the z-intercept, I'm going to make x equals 0, y equals 0. So this is going to be 0 plus 4z equals 12, or z equals 3. So we're looking at the point 0, 0, 3. So let me graph that. So 4, 0, 1, 2, 3, 4, 0 is here. And then I have my y value, so it should be on my y-axis. So that's 6, 1, 2, 3, 4, 5, 6 here. So that is 0, 6, 0. And for the z, it would be up at 3, 0, 0, 3. So the plane is actually here. Now, if the equation of a plane has a missing variable, such as 2x plus z equals 1, then the plane must be parallel to the axis represented by the missing variable. So if you do the same thing, to find the x-intercept, we're just going to let z equal 0 in this case, because there is no y. So therefore, we get 2x equals 1, or x equals a half. Then I can find the z-intercept. I have no y-intercept. And so I'm going to make x equals 0. So 0 plus z equals 1, or z equals 1. So then just to kind of label these points to help me out. So I'm just going to call this one point here. This is my half 1, half 0, 0. And then for my z, it's at 1, so just to scale it, it's up here. And so notice I have these 2 points that connect. And so there is no y value. So what it's saying, it's parallel to that axis, right? This is a plane. Like, it doesn't really stop at those points, but this is a plane here. And then it's, okay, there we go. Something like that. And so it's parallel to that axis. Now for the last example, if two variables are missing from the equation of a plane, then it's parallel to the coordinate plane represented by the missing variables. And on the right, I'm going to show you a little bit of the pictures, a little bit more of the pictures. So if we find here z plus 2 equals 0, so we find that z equals -2. So -2 is down here, and it's always -2, so we actually have a plane all the way down here. So notice that it is parallel to the missing variables, right? So it's parallel to our y and it's parallel to our x. And let's look at some nicer pictures of these. So for example, here, if you have ax plus d equals 0, it's parallel to the yz plane. There's no y variable, there's no z variable, so notice it's parallel to the yz plane in pink. Then if you have b here, you have the y value here, then it's parallel to the xz plane. And then if you don't have xy, then it's parallel to the xy plane. So that's kind of what I was trying to draw. It's kind of hard to see, and with the pictures that is much nicer. So hopefully that helps you out with the graphing parts of the homework.